In this example on 3D vectors, we're going to take a look at problems in 3D. So point A has a position vector of minus 4i plus 3j plus 6k, and point B has a position vector of 2i minus 5j plus 3k. Now point C lies on the vector line AB, and this divides the line in the ratio 4 to 3. Now what we want to do here is find the position vector of C. So in this case here, what it might help is to draw a diagram. So if we draw a diagram here, we'll obtain something of this form. And this is just a bit of a sketch here just to help visualize this problem at hand. Now, what we want to do here is understand how this ratio works here. So we're told that C divides this line, AB, in this ratio 4 to 3. So the first thing we can note here, that in this case then, from A to B and A to C, well, A to C is going to be 4/7, okay, because this is in total 7 parts. That's going to be 4/7, okay, so AC is 4/7 of AB. What we also need to understand is to find the position vector of C. That's going to be O to C, okay. So in that case, we're going to need OA plus AC there, okay. And to find AC, like we just said, that's going to be 4/7 of AB. So let's start putting all this together now. So first what we're going to do here is find AB. So find AB first. So to find the vector AB, well here in this case, that's going to be the position vector of B minus the position vector of A, okay. Well, in that case, OB here, that's going to be this position vector. So it's going to be 2 minus 4 for our I component. So that's 2. That's my B component here. Minus 4. So minus 4 here. And that's for our I component. Okay. Do the same for the J component here. So this is going to be plus minus 5 minus 3 here. Okay. That gives us the J component. And finally for the K component here, it's going to be 3 minus 6 there. Okay. Well, if we solve these individually, 2 minus 4 gives us 6i. Minus 5 minus 3 gives us minus 8j. And finally, 3 minus 6 gives us minus 3k there. Okay, so that gives us the vector AB. Now, like we just said there, C divides the vector AB in the ratio 4 to 3. So therefore, as we just mentioned, C is 4/7 of the vector AB. Okay, so in that case, we can work out then the vector AC by doing 4/7 of AB here, the vector AB. Like so. And in that case then, that's going to be 4/7 of this vector here. So we write that in full here. Like so. If we simplify this then, what we'd get here is 24/7i. 24/7i minus 32/7j. And finally minus 12/7k. Okay, so that gives us the vector there, AC. So here now what we want is the position vector of C, so we need the vector OA plus the vector here AC. Okay, so therefore for the position vector OC, or the position vector of C, OC here, that's going to be the vector AC plus OA. Okay, don't matter which way we do this addition here, obviously. You could have put the vector OA plus the vector AC, but again, that doesn't matter. So in that case now, if we do this addition here, again, splitting this up into the I component, the J component, and the K component, we're going to get 24/7 minus 4i, so that's our I component, plus minus 32/7 plus 3, that's our J component, and then finally if we just do this underneath here for our K component, this is going to be minus 12/7 plus 6. Okay, so that's our K component. And all we've got to do here now is just simplify each bracket individually. So if we give our final solution in a different pen colour here, so therefore OC here, the position vector of C, is simply equal to, simplifying this I component here, that gives us minus 4/7i. Simplifying the J component now, minus 32/7 plus 3, that gives us minus 11 over 7j. And then finally, simplifying this k component here, minus 12 over 7 plus 6, that gives us plus 30 over 7. Okay, so ij, and that's our k component there. Okay, and that gives us the position vector of C, giving us the solution to this example on 3D vectors.